Assalamualaikum. So we from Group 4, we going to presenting about HeyJom application, database design and development. What is HeyJom? HeyJom is a centralized sport event registration and management platform that connects organizer and participants through efficient database management.
Next, I'm going to introduce our team members. First, we have Nur Fatiha binti Hasim, Sarah Azwa Aisyah binti Azman, Marsha Rahani binti Abdul Razak, and Nurul Balkis Husna binti Ahmad Fauzi.
Next, this slide shows the organization structure of HeyJom. At the top of organization is Patricia Tan, who serves as the founder, CEO, and board of directors. She is responsible for leading the company and making strategic business decisions. Supporting the CEO are the management teams, including James Tan, who is CSO, and Luke Fong Peng, who serves as CFO and Operations Director. They oversee the company business strategies, financial management, and daily operation. The organization also includes several departments with specialized roles such as sales operation executive, senior project manager, IT project manager, technical leads, web developer, software developer, mobile application developer, senior iOS developer, and QS specialists. This organization structure allow HeyJoom to manage its business's operation efficiently while continuously developing and maintaining its sports event registration platform. HeyJoom Company background. The first headquarters is located at Kampung Sungai Kayu Ara, Petaling Jaya, Selangor, Malaysia. The businesses is focused on online sport and fitness event management platform. The key features that have on HeyJump application is create and manage sport events, browse and register for events, virtual event participants with distance tracking, flexible online payment options. The target market for HeyJump is fitness, sport lover, event organizer, and sport brands. The market focuses on Malaysia and Southeast Asia.
Next one is problem statement. The first problem statement is the absence of a proper database system makes it difficult for organizers to manage participant information efficiently, leading to a data redundancy and inaccurate participant details. Next, managing and monitoring payment transactions manually can cause difficulties in tracking registration payments and generating accurate financial reports for sports events. HeyJoom provides a digital platform that helps organizers manage payment transactions efficiently for sports events. Poorly structured data relationships may cause data inconsistency due to a lack of proper primary key, foreign key, and entity relational structures. And the last one is without a secure systematic environment, sports event records may be exposed to risks such as data loss, unauthorized access, and difficulties in long-term data storage and maintenance. Our objectives is to develop a database for managing participant information in sports events, to manage and monitor payment transactions related to event registration. Next is to improve data integrity by establishing primary key, foreign key, and entity relationship model entities. And the last one is to establish a secure and systematic database environment for long-term storage and maintenance of sports events records.
Next, I will present to you about database design, which is a business rules. Before we design our database, we study on how HeyJump actually operates and translate their real business policy into rules that our database must follow. This ensures our database reflects on how platform is truly work. Based on our study on Hejo platform, we identify 9 business rules that show how data is created, managed, and related with the system. This is a covering organizer, participants, events, registration, and payment. For today's presentation, I will walk through a few key examples that show these rules shape in our database design. For example, one of our rule is the system must contain organizer information for managing sport event. An organizer can manage many events, but each event belongs to only one organizer. This is to explain a one-to-many relationship. Another rule state is a participant may receive multiple events and each event may receive one registration. This is a show how registration act as a bridge or junction between participant and event. And the last one is every payment for every registration must be updated in the system for every successful transaction. So this explains that every payment must be linked to one registration. This is to ensure no payment exists without a valid registration record. So this is also to show a data consistency. These business rules, along with the rest list in our report, this is to form the foundation for our normalization process and ERD diagram, which is I will explain next. Next, I will explain to you is a normalization, which I will start from zero normalization or unnormalized form. So zero normalization. This is basically our raw registration form before any database structuring. Everything participants fill in with their own details, the organizer info, the event info, venue, registration, payment, and risk all inside one single record, as you can see. Beside that, in the registration form, you can see the curly bracket actually represent repeating group. For example, if one participant register for multiple event, the event or organizer or venue details would repeat inside the same record. This is a messy and not usable in a relational database. Next is a first normal form. As you can see, in first normal form, we flattened the form. So actually, we remove the repeating group by listing every attribute individually in one flat table. At this stage, we have not split anything into separated table yet. We just make sure that each field only store one single value. So as you can see, that we state here, it's still one giant table. If the same organizer runs 5 events, their name, phone, and email would repeat 5 times. That is a redundancy. So we still need to break this down further. After that, second normal form. In second normal form, we start splitting our data that did not depends on the fully combination of keys. The clearest example is participants. A participant name, IC number, and phone do not depend on which they registered for. So we separated participant into its own table. So as you can see, we have a two table which is a participants and registration details. So participants is clean now, but for registration detail, it's still a big table, which is it contain organizer, event, venue, payment, and risk kit info. They are still together, and they do not all directly depend on registration ID. So we need to add one more step to separate them. So the last one is third normal form. In third normal form, we split registration details further because things like organizer details depends on the event, not directly on the registration. Similarly, with the venue details, which depend on the event and not on the registration. So we put organizer, event, venue, race category, payment, and risk it out into their own separated table, which its own primary key. As you can see at our slide, now every table represents exactly one real uh, entity with every non-key field that depends only on its own primary key and relationship that are maintained through foreign key. This gives us 8 clean tables with no redundancy, and it is ready to turn into our ERD. So to conclude, our normalization help us go from one messy repeated form into 8 clean independent table, which each representing a single entity connected through primary and foreign key. This gives us a solid foundation before we move into designing the ERD diagram.
This slide shows ERD for our proposed Helium database. The ERD illustrates how the 8 entities are related to each other to support event registration process. First, we have organizer entity, and organizers store information such as organizer names, phone number, email, address, and person in charge. One organizer can organize many events, but each event is managed by one and only one organizer. Next, the venue entity, which store event location including the venue name, city, state, country, and postcode. One venue can host many events, while each event is held at only one venue. The event entity contains information such as event name, date, category, status, and start times. It is connected to both the organizer and venue through foreign key. The participant entity store participant information including personal details and contact information. A participant can register for multiple events and every registration is belong to one and only one participant. The registration entity acts as the bridge table in our database. It records the registration status, ticket size, and connects participant with event and race categories using foreign key. The race category entity store information about different race category such as category name, race distance, minimum age, participants limit, and entrance fee. Each registration is assigned to one race category. The payment entity records payment informations, including payment dates, amounts, payment method, payment status, and receipt number. Each registration generates one payment records, allowing organizer to monitor payment transactions efficiently. Finally, the race kit entity store race kit collection details, including the bib number, collection location, collection status, and collection dates. Each registration have only one race kit assigned for participants who successfully register. Overall, this ERD ensure that all entities are properly connected through primary key and foreign key.
Next, I will present about the testing and implementation phase of our system where we have test all the function in the Helium registration system. So in our main interface, there are 5 buttons, which is the participant information button, the new registration, the payment management, the event details, and the generate report. So to make a new registration, you can click the new registration to add new participant. So enter the participant ID, the participant name, the participant IC, participant gender, participant age, participant phone number, email, and the emergency contact number, and then click add record to save to our new record, and click register to add the new registration based on the participant ID. So first enter the registration ID, status, payment status, the event name, category ID, event ID, and participant ID, and click add, and you can view the list of race category to make the payment based on the entry fee, and then continue the payment, enter the registration ID based on the registration. So enter and payment ID, and then enter the payment date, amount, method, status, and payment number, and enter and click add to save the record, and to view the participant information, click on the button, and we can view the registration details based on the participant ID and the participant name that we have entered. Next, to see the payment details, you can click on the payment management and enter the payment ID, and we can see the registration details, the total payment, the payment status, and payment date based on the payment ID, payment amount, payment method, and the registration ID that we have entered. And next, to view the event details, you can click on the event details button, and you can check the event name based on the event ID, and you can also check the venue based on the venue ID. And next to view or to generate the report, you can click on the report button, and you can choose whether to view or to print the report. If you choose to view, you can view all the data for registration report. And if you click the print button, you can see there is the page for you to print all the report data. So to conclude, we have successfully developed a relational database for the Hejom platform using the database lifecycle. We have designed a complete database structure with business rule, 1 normal form until 3 normal form, ERD, and data dictionary. And for implementation, we have used SQL create table and insert statement to build the database in the Microsoft Access, and we have verified the database through the testing and SQL queries, and we have achieved all the 4 project objectives by improving the participant management, payment transaction monitoring, data integrity, and secure and systematic data storage.